Hi everyone, so we're talking about conceptual understanding and procedural understanding. A lot of times we hear this word understanding, but it's really important to talk about procedural understanding and conceptual understanding and what's the difference between them and which one should come first. Okay, so procedural understanding, a lot of people have heard procedures, algorithms, so they're like a recipe, they're the steps. So you just memorize step A, step B, step C. However, conceptual understanding is how something works, why something works. And the critical point is you are understanding the map. So if you think about how the brain works, the conceptual understanding is more like a rhizome. It's more like a spider's web where things are interconnected. You can travel down a path, and if you get stuck, you can move sideways and then down again to solve the problem. Unlike when you're thinking about procedures, it's more like chain links. And if that one link is missing, that one step is missing, you're going to forget. So it's very hard to access and retrieve if you just focus on procedural understanding and not combining those two together. So conceptual understanding first and then procedural. Now a couple other things with that. To really understand conceptual understanding, what you want to do is have a visual representation, an iconic representation. When you have the visual, you're actually seeing it. And that visual spatial working memory is so critical because that helps you actually go from that visual idea to the abstraction, and it helps you remember and retrieve things over time. So we want you to be thinking about conceptual first before procedure. Last thing on this one that's really important to know is a lot of times we as teachers, parents, we didn't learn it conceptually. So that means it's really hard to teach it conceptually. So sometimes we have to step out of our comfort zone and figure out what is the concept here. I'm going to walk you through an example with equivalent fractions. Okay, our focus has been on conceptual understanding and procedural understanding. We're going to do an example with equivalent fractions. So with equivalent fractions, have 2/3 times 2 halves. And so as we're teaching that, we tell kids we're going to multiply the numerators. 2 times 2 equals 4, and 3 times 2 equals 6. So 2/3 is an equivalent fraction to 4/6. That's what we focus on. That's the procedure. However, we want to give them a conceptual understanding. Now, as I was saying before, an iconic image, visual, is the most important. So I could do that on a number line. Number lines are awesome. And so I could say, okay, so here's 0, and here's where 1 is. So another video we talked about using the word 1 versus whole. It's a whole unit, but a unit of 1 is really important. So the 3, the numerator, go here. The denominator 3 here is going to tell us to partition from 0 to 1 into 3 equivalent units. The 2, the numerator is our count, so we're going to count 2 of those. 1, 2. A lot of times we say parts out of whole. It's more important on the number line to talk about that count and then the partitions here. Okay, so that's where we have 0/3, 1/3. There's our 2/3 and 3/3 here. Okay, then we go to this 2. This 2 actually tells us to partition the third unit into 2 equal units right there. So we have a new unit. So I do that with each of my third units. And now it takes 1, 2, 3, 4, 5, 6 of those smaller units to get back to 1. So these are called 6. And this tells me I'm going to take 2 of each of my count of 1/3, 2/3. I'm going to take that one, that one, that one, and that one. And that gives me 4/6. 4/6 is equivalent to 2/3. But this gives me the conceptual understanding of how and why this procedure works. That's why we do conceptual first, then procedural.